Looks like we've got a number of folks joining now, so I think we can go ahead and get started. So the main topic today that's on the agenda so far is around the manager and metrics collection and how we can improve the scalability of that in general. Did somebody want to take this discussion away?
Hey, I think I may summarize a bit. So this is related to the testing that Paul is doing in the Scale Lab. And he recently found that, well, you have the details in the document, but he has a, thorough document on the scalability issues that he's been facing. And most of them come apparently from the manager Prometheus exporter. So, and specifically to the perf counters. So he reported like 600,000 metrics, different metrics per script interval for 2,000 OSDs. So that's huge, and that's causing a lot of, issues. So that would be an intro to the main issue there. And he's also proposing, apart from these two ideas, he's also doing some shorter term fixes, like creating a list of an allow list of the metrics that we do really want to export in the manager Prometheus. So not to export every metric, but only the ones that are really used in Grafana and in Prometheus, the error manager basically. And yeah, so and today he was also sharing this in a meeting. I'm not sure if the recording is public, but I think Patrick and Tatiana were there. I definitely missed that one. Yeah, but that's all the context for the issue.
Okay, thanks, Ernesto. And so I think there's like three different proposed approaches, maybe talking about two of them around separating the exporting metrics out into separate areas to send them directly from where they're being collected to Prometheus and bypassing the manager, and possibly doing that within each daemon or possibly one daemon per host. And the third idea would be to continue doing it through the manager, but trying to scale out the manager more.
I think the initial idea was to put this in every daemon, right? In every Ceph service or daemon, submodule or subcomponent that basically would export this. Paul mentioned that he was talking with, I think, Casey, and they basically raised concern on the fact that, well, adding this kind of logic, basically an HTTP endpoint, might pose a risk, right? Security-wise, and yeah. So I think that's why he also suggested the other approach, which is putting this collocated exporter in every node.
And they know what they need to do as well.
So yeah, deploying this collocated exporter in every host just to avoid the having to have that in every single service.
I guess the question that comes to my mind around that idea would be, how do you know that you're going to be able to deploy it in every single host where things are running, and how do you set up that communication between all the processes on that host?
Yeah, that might be trickier. I think I remember Sebastian saying that they were talking about that in the past, how to do the discovery or service discovery or the kind of discovery. I'm not sure if with for the RBT mirror or something, but I remember that Sebastian mentioned that. Adam is here. Adam, do you know about this conversation about how to discover the exporter endpoints in case that we go with this approach?
So just for discovering the RGW endpoints. I think when we talked about it, it was going to be like Ceph job to configure depending on how we did it, whether we wanted to have it, if it was directly on the RGW, we had to configure Prometheus to know where to look. I think if we had its own thing, scraping things, then it was going to be able to configure whatever that is. But, so I think we were going to handle it.
So to be clear, the current scalability problem is that the Prometheus module is getting about 50 megabytes of data for the whole cluster on every call into the manager. Is that the only current scaling issue?
I think it's the one that Paul is right now directly hitting. I'm not sure if once we remove that, we will hit another one. Because I mean, on one hand, yeah, please.
I just wanted to say it's not necessarily the amount of data that is returned, but it takes time to collect the data, and Paul has looked into how parts of the collections are done and how much time it takes them, and there were some odd results. Probably he said it like that there would be victims rather than causing the issue. Parts of the manager took them longer to collect the data than was reasonable, probably due to some locking inside the manager, which is probably already an issue. So not necessarily only the amount of data that is gathered, but that the logging is so heavy that it could possibly also affect other manager modules and cause some issues on its own for the manager.
I think I can share my screen just to display this doc that Paul has been working. So it's basically a chart of the scaling of the cluster and how the scale of metrics ground. So let me try that. My screen?
Huh.
Yeah.
Okay. Yeah. So I think these are metrics, and Patrick, probably you will know this better, right? Come directly from Prometheus. So the Prometheus exporter is also exporting its performance metrics as well, right?
It is by default, yes.
Yeah, that's the amount of OSDs versus the amount of metrics, I think, or how the number of metrics is increasing. So as you may see, yeah, in this worst case, this 600, more than 600,000 metrics. Not metrics, but samples. So a single perf counter may generate full samples per OSD, for example. So yeah, that explains the amount of metrics. And I think he later disabled all the perf counters, and yeah, we got just 30,000 metrics instead. So most of them are perf counter related. And I think then later enabled just the ones he ran an allow filter just to only let pass the metrics that were actually used in the dashboards, and that counted for like 80 something thousand. So that's still far from the 600,000 metrics
Exactly.
that we are.
Yep. So by default, we have most of them unused but enabled, and it causes issues. And if we cherry pick only those which we really need, it scales to, let me see, around 4,000 OSDs easily.
Yeah.
Probably not so easily. I mean, I've seen a chart where it was scaled up to 8,000 OSDs, I guess, but that was pretty much the limit for single Prometheus instance, even though the perf counters were reduced.
Well, it's the case too that we're not only we have metrics we have, but we're trying to
Yeah, you're very quiet. Can you turn up your volume? Or
Forgive me, is that better?
yes, thanks.
Yeah.
Okay. I just merely was to say that not only are we trying to scale the metrics we already have, not reduce the number, but we're trying to increase the scope of metrics and particularly as regards replication, we have a bunch of specific intent there. Like we're trying to report on replication activity per volume or per bucket and other things along those lines.
Yeah, but Matt, in the worst case, how many extra metrics that would, or samples that would bring? Because here we are talking about a huge difference. I mean, that's probably explained because all the, instrumentation.
So I missed the big first 4 minutes of the call, but I mean, is the proposition? Are we rejecting the proposition that I thought had been agreed by Jason, by consensus in previous meetings? That routing all metrics through the Ceph manager is now a tolerable topology? Because I don't think it is.
Yes, what we see here at the screen shared by Ernesto is the solution we can implement in the Ceph manager module. Sorry, yeah, Ceph manager Prometheus module, and that will help a lot. But there will be a point where it might not be sufficient anymore. And considering that this is the whole data is going through one point,
Right?
Basically a bottleneck.
So that remains the the axiomat. That remains the premise of the discussion that in fact we want to eliminate this. I think that's extremely plausible.
I think the intent was, Paul's intent was there's two problems. I mean, one is the ability to, scale through a single manager instance, and the other is, the fact that we have all these metrics and a lot of them aren't even needed. So as a result, he's showing two different things, and I think we have to fix both problems in the long run. This is how I would interpret my conversations with him. So.
Well, sure, but okay. I came to this meeting believing that we had at least one accepted item that we were going to change the topology, work on the design.
Yep, and I believe the same, Matt. So.
Yeah, I don't think anybody's disagreeing that one Python process is not going to be able to handle a large scale of metrics. I think we all agree on that aspect of things. I think there's 3 different ideas outlined in the wiki. One of which would include is explain the manager more to have active managers. Others are the ideas that we discussed earlier about trying to add make the metrics be exported directly either from the daemons using or running in various places directly, or via the third-party daemon that would be exclusively for metrics collection and export.
Understood.
Josh, or anyone else, is there anything that prevents the manager from handling metric collection at different frequencies? Like if there's data that we only want rarely, every hour, every couple hours, is there anything that prevents us from doing that right now?
No, that's another option. That's an interesting thing to think about. I'm not sure if Paul has looked into that. I'm not sure. It'd be a good idea to look at that in terms of individual metrics. There are probably a lot of perf counters that we don't necessarily need all the time, but a lot of these things are things that you would want in a monitoring system where you need to assess like the health of the system at a pretty frequent rate as well. So I'm not sure like every hour would be sufficient for a lot of things.
Yeah. But maybe some things don't need to be updated as fast as others.
Sure.
That's
jumping on that. We could have like high priority, low priority metrics. High could be like a certain budget per per call, and then like some are put in a queue and reported when there's budget left. Like maybe we allow 1 megabyte of metrics per call. That way you don't have to say like you don't have to set a frequency for them. You just report them as quickly as you can. You know what I mean?
Sure. Yeah. And just the low priority ones do it randomly, right? So you don't end up just collecting the first, whatever ones out and then ignore the others.
I think or just be a queue so that the frequency is relatively. There would just be a first come first served queue, and then they're just reported with the same. The period would be relatively constant, but it might be 7.3 minutes or something. Or you know what I mean? It might be just depending on the number of metrics to report.
Honestly, that is using a single exporter. Not I can't think of a way to implement that using a single exporter. Having two of them, one with higher, one with lower priority, that would work. So that Prometheus would be configured, because Prometheus is pulling the data from the exporters. It is not pushed to Prometheus. Prometheus needs to be configured to scrape the exporters, and so either we would be very selective about having a metric in the snapshot of the exporter, or we would need separate exporters for Prometheus to be able to scrape them at different intervals.
Well, I mean, just to clarify what I meant, the interval would be scraped like every minute or every 15 seconds, like now, but it would report different metrics. The low priority metrics would be it would be a different set each time you call it. Maybe this is not.
It's an interesting idea. So how would the graphs look like if Prometheus is configured to get the metrics, but the exporter is only part of the time returning the metric, returning a specific metric? So how does that look like for Prometheus? Is that a gap in the data? I'm not sure. I don't know.
Not sure. I know that Grafana can keep the last.
Yeah,
point,
it will be a graph. It will be a gap.
You'd almost need to adopt. Yeah, you'd have to adopt graphing methods that would assume the possibility of non-constant intervals, right? So you'd potentially need to, smooth over periods where you have less data or more data. But you could, but the alternative, right, would be that you just have low priority that has consistent intervals, but just doesn't happen as often.
This seems like a separable problem from the topology and graph to getting metrics to Prometheus, and therefore could be dealt with at later, revisited at any time.
Yeah. So the wording in this wiki document, it seems to be specific to RBD mirror, CephFS mirror, and RGW. So it's not clear to me if we're talking about perf counters everywhere, including OSDs and otherwise, or if we're just talking about replication metrics. But something that I recall from discussions around RGW's multi-site metrics is that we want very fine-grained stuff, like stats per bucket. And with Ceph's perf counters, all of the keys are hard-coded, and so we have no way to have like dynamic per bucket metrics through perf counters. So are we talking about extending perf counters for stuff like this, or are we talking about a new completely separate channel for Prometheus?
Actually, in the
well, I think that
yeah, please.
Yeah. All right, I'll just go ahead. I think this ties into the topology question, right? Because I'm not sure why the like a case where each individual daemon would set up an HTTP endpoint and report metrics by itself got scraped, but because that was the approach that I thought was agreed upon
I also.
a long time ago. But with that approach, we would cut out Ceph perf counters, right? The daemon has all the flexibility. It can do whatever it is that, like, basically everything that Prometheus allows. We don't need to first somehow package the data that we want to export into the perf counters framework, then get those perf counters sent over the network, whether it's as it is today to the manager, or as this thing seems to suggest to local daemon, which would then unpack it and right. So I think the perf counters, whether the perf counters need to be extended to be more dynamic, depends entirely on like which of these ways.
Well, originally, isn't it true that perf counters weren't a network protocol that was added later after Ceph Manager came? So one accessed perf counters, and so can daemon, the daemon socket, particular Ceph daemon. So if you so those are composable to support all the existing perf counters. One is to compose them by the exporter. If we wanted to, but everything Casey said is correct. People are asking us, or RGW, and I think it's true of the other replication services too, to send more things, send more structured data, sparse data. I think, unfortunately, but replication counters per bucket is one. But we've talked to Prometheus experts, including Paul, about that, and they've said, well, there are Prometheus data structures, data types that probably cover that space. But yeah, we wouldn't need to put them into the perf counters. We wouldn't even the original notion of perf counter wouldn't necessarily need to be expanded. But of course, the individual daemon or W in this case would need to track that. They could present it to an exporter. But the idea that came up, as I understand it, I don't know if it has been. Apologies if I'm recap if I'm restating something that was said before. The idea of having the intermediate daemon or agent-like thing, repackaging counters was something that I believe was brainstormed in a meeting that I was, but Paul and I and Casey and a couple other people were in, because in response to an argument made by Casey that it was uncomfortable with the converged exporter, the exporter in RGW itself in this case, or in an RBD itself, saying that this presented a potential security problem. That especially if it were publicly accessible, new attack surface through third-party HTTP processing code. A couple of bad problems, a couple of warning bells there, and that to increase security, you wanted to separate the job of the exporter from the job of the daemon. And Paul's proposal was, well, the sidecar can be a device, a component on the node which absorbs the counter data and then exports it Prometheus compatible style.
Right. And my concern isn't so much about RGW having an embedded HTTP endpoint, but I'm trying to understand if Ceph OSD is in scope also, because vulnerabilities there could take out the whole cluster, right?
It is in scope. If from Prometheus' point of view.
I mean, exactly.
Yeah, but exporters should not be part of the OSD. As Matt said, it can be a sidecar or.
I was in the camp. Let's get all the cards on the table. That's Casey's view, and apparently that's your view. My position would have been that it is possible that one can safely have the exporter in an OSD and bring the access to that to trusted. If we can't do that, then we end up with then the sidecar design is.
I have a suggestion. So a lot of this clearly stems from the Ceph manager module that needs to re-encode all of the performance data that the manager is collecting from the manager reports, and then organize that into data which can be queried through the command line interface. That's clearly non-scalable and the core issue here, I believe. So my suggestion.
Just to clarify, I mean, isn't it the case that routing all the information through a central Python daemon back?
So
another way of saying the same thing, because I think it's.
Let's back up a step, Matt. I think routing all the data through one process is not a scalability bottleneck for the amount of data we're talking about. Problem is how we're doing it through Python. So my suggestion is that one option we could explore is having in the C++ side of the manager, storing all this data in Rados, probably on libceph SQLite. And there exists methods for having Prometheus scrape this data out of the SQLite database.
Just wait a minute. I think you've introduced a couple different concepts there. I mean, do you actually think it needs to be materialized to stable storage? Because that's what sending it to Rados and SQLite means, and also indexed, which I think.
Well, I think the convenient part about this, Matt, is that we can separate out the exporting of the data from the manager, and storing it in SQL allows us to do some natural things like build queries, which Prometheus would be able to then use. So I just did a quick Google, and I pasted a link in the chat for one such project to query SQL databases for Prometheus, and that should work with SQLite, and that would be an option for the manager to collect all the data, store it in Rados, and then let the Prometheus itself scrape that out whenever is convenient for it. We don't even have any communication going on between the manager and Prometheus.
Well,
it seems like you've changed a lot of rules there. I mean, you've changed, moved the topology speed up that was original theory of what the scalability problem was, but you moved out of the Python problem, which with the Python the GIL executor problem, which I think is real, and so it solves that. But now it moves. But it also up levels the model, the information model, to be one where the data is indexed in stable storage. It's cool. I mean, that's more powerful, and you can build all kinds of interesting tools with it. But Prometheus ends up then kind of mirroring data that's already stable in Rados. It changes the semantics quite a lot by doing that.
Also, it's double persistency because Prometheus basically persists the metrics and allows queries. So you like
correct
what Prometheus is doing basically.
I was trying to say the same thing. It's turning ephemeral data that Prometheus stabilizes into data stabilized in Rados.
Patrick, regardless of the less persistence piece, which I think is a separate issue, what you're talking about in terms of moving the processing and making it more efficient to be in the C++ code rather than the Python code, do you have an idea of how much of the bottleneck is in one area versus the other, or how much we could scale if it was purely implemented in C++?
So if we organized all the performance data in C++ structures and then allowed Python to call into the C++ code to get whatever it needs to satisfy some CLI command, that would potentially be more efficient. How much so, I don't know. I mean, there's also the complexity of the Prometheus manager module setting up an HTTP server. This is not code I'm very familiar with, so I'm not really sure how much of an impact this would actually have.
Very significant if we could remove the Python from whatever data, from all the data flows. So it's a single process, but you can scale a lot.
But I would, I mean, the double persistence sounds like a drawback, but I think there's a lot of utility in keeping the performance perf counters for all of the daemons in some central location that's queryable. This would have wide utility beyond Prometheus, other manager modules.
That's exactly what Prometheus is as well, right? It's a centralized place to store metrics and query them.
Correct.
Sure. We have to teach all the manager modules how to talk to Prometheus to get the same data. It's just another way to get at the data.
One thing I wanted to add, isn't this what we're trying to achieve with tracing, OpenTelemetry? Like we are deploying a sidecar, and then with a trace we can kind of plug in the matrix that we are interested in form of logs, and this could be stored in the local host where our daemons are deployed. In a collector daemon, and then from these daemons then can export those metrics to Prometheus. And this blog I linked specifies something similar, and I think from previous discussions we got to know that OpenTelemetry is kind of creating a local HTTP server kind of architecture. So would that suffice our use case here, or are there some loopholes?
I don't think the tracing and stats collection are the same thing. Those are different functionalities. I agree that the architecture that they have with tracing, where you have a sidecar which is co-located with the daemon that is being traced, and then it sends that to the central location, is a good architecture. And if we can do that with Prometheus, we should probably follow that. But functionality-wise, it's a different thing. I would not try to force the tracing mechanism to be used for stats collection.
Mm-hmm. Okay.
Yeah, this is I agree with you. Well, sorry, go ahead.
So I was saying that, like actually between metric and trace, there is a link that you can have, which is called exemplar in the Prometheus exporting format, which is open metric. And it would be nice that the daemon talk directly this format, because then we could have all this native Prometheus data structure, and we could easily add those links to traces. That means basically that in your dashboard, you will be able to click on metrics and have this trace ID and just open Jaeger directly. So it doesn't mean an architecture specifically, but yeah, having all the daemon talk open metric would, I think, allow for new data structure available in Prometheus. I think we don't have histogram as well. Not sure about that, but yeah.
Yeah, but we should separate tracing from metrics. These metrics are connected to alerting and other things. And usually they don't need to be fine-grained as tracing. And we usually set them on, like in tracing, usually you can set on off. But basically the idea of this exporter, it could be exporter per node, exporter per daemon. We can think about the topology, but in any case, like in Kubernetes, usually there are lots of exporters. They don't do a centralized exporter. You have node exporter that actually takes the node performance counters and stats and export them. You have per daemon exporter. Different services do have different exporters. And you don't have a centralized point, because basically Prometheus becomes the centralized point.
I'm not super familiar with the Prometheus model, but from what folks were describing earlier, it sounded like you needed different exporters if you wanted to have different sampling intervals and different sets of things being collected.
Yes.
Okay.
Because it makes sense for Prometheus to have specialized exporters. It is also easier to get Prometheus that way. You can eventually use a Prometheus instance to scrape all node exporters, another instance to scrape all OSD exporters, if I may say that, and then RGW and whatever. And that way there would be no bottleneck, no single bottleneck, no single service. And if I may add that, I don't think the Ceph exporter has a performance issue because it runs Python and Python is so slow. I do agree that there's a locking issue. I guess there's a locking issue.
There's a locking issue. The entire interpreter is single-threaded.
Yeah,
yes.
I observed it when Sage and I were looking at it. There's definitely issues there.
But what the Prometheus exporter does is it only requests the data from Ceph on all different nodes. I don't know how the data is gathered Ceph internally, but then it receives the data and it does not a lot of processing. It just outputs it. So it is not very CPU intensive. The problem is likely the locking. And
well, every 5 seconds sending 54 megabytes of data to be processed by Prometheus is a lot. I mean, so independent of, and that's what we've been seeing at scale. And I don't know if Ernesto mentioned that earlier, but that's a lot of damn data, every 5 seconds. So I think, going through one point to get all that versus multiple points. I mean, it's definitely got to scale. You've got to go to, some type of distributed architecture for the scraping. We also have a reduction in the data that we have to do. And I think we need more POCs. And I think the interval thing is probably more of an enhancement in the, as we fix all these other problems as we move forward. But yeah, that's a good feature to have as well. Couldn't agree more, but we got to figure out what that means and how it works. And, I think a POC is required for that probably as well, unless someone knows how that all works today. I mean, Paul might have the answer, but I don't know if anyone here does. I mean,
well, for the interval part, it sounds like if it's controlled per exporter, that suggests that it might be more useful to go with the per daemon approach if you wanted to have a separate exporter rather than per host, so that you could have like that per daemon control over what is it being exported.
But even from a per daemon perspective, you might have different intervals for different metrics that you're collecting on a per daemon basis. So, I mean, I think we've got to do a little more investigation there personally. But
Sure.
We don't right now, right? But we could in the future, I think, is the thought. As I don't believe we do, right?
Correct. It's fixed. I think they're all fixed intervals if I remember correctly. And yes.
I do think there could be some short-term wins, though. Definitely, even if like 50 megabytes per second every 5 seconds, it's really not a lot of data in total. I think it may be like what Patrick's suggesting. Some of it is about the processing, like making it go through JSON or through Python to transform into textual representation. That could potentially be one bottleneck that gains us next level of scalability. Not clear to me whether that would be sufficient for supporting, say, a 8,000 node cluster or not with the current level of metrics, but I think it might be another avenue worth investigating in the short term.
Well, I don't know. To me, 54 megabytes every 5 seconds for a 3,800 node, 3,800 OSD clusters feels like a lot to me. I don't know. I guess I just view it differently. So,
Well, I liked when Jason first proposed it, I guess, but it was the topology change. I think it is I think it has a couple of discrete goods. I think it's I think the proposal to change. I think it's compatible with different ways of embedding the different exporters. In case rates view that it shouldn't be in converged with OSDs or RGWs is legit. There's good arguments for that. But it works the same. But the approach moves the data between more between the target, the sources where it originates, and the targets where it wants to be. It lets us arbitrarily scale, and those M to N relation cardinalities doesn't require any further software changes in the Ceph system to do so. It does, it sacrifices some of the expressiveness in the Ceph system that Patrick aspires to, but it satisfies the goal of cooperating with the highly evolved Prometheus infrastructure, which is specialized for that.
Yeah, I agree, Matt. I think we definitely need to do the scaling out approach longer term. Suggesting that the existing Python implementation could potentially be optimized for example, stable releases.
Oh, sure. But I guess I'm expressing with Ceph that I would like to see the scale out prototyped, prove it, and see if it runs into problems.
Yeah, I agree.
Do we have any insight right now into how often we send repeated data? Like if we have a 0 at every interval, are we resending that 0?
You will be resending the value.
It'd be interesting to know how often we're sending the same value, what the difference would be if we only sent changes.
No, the same value is repeatedly requested from Prometheus and sent to Prometheus if it has not changed. And every 15 seconds by default, which is, by the way, the current default interval for scraping the exporter is not 5 seconds.
Did you say that it will only send the data if it has changed? Did I hear you right?
No.
The other way around, it will be always sent.
Yes, if the Prometheus does in simple terms, it does an HTTP GET, and it fetches everything that the exporter returns, and the exporter is supposed to be done, and just exporter is supposed to return all the data of the instant where it is requested.
And is that data in just a straight text format?
Yes, it's a text format, and like it was said previously, it's an open metrics form, but it's plain text.
Okay, plain text. So no delta encoding or anything else that would get us an improvement in compression.
Well, HTTP can do the compression, but I'm not aware of if it does that already or not, but it would make sense.
Maybe, I don't know if it's time to ask a related topic to this, but do we have a good sense of when the manager is slow or broken, where it brings the rest of the cluster down or causes problems doing other things? Is this something that we can fix independently? Like slow metrics shouldn't cause other problems in the cluster, right? Ideally.
It's not supposed to. I mean, this is why all this stuff was moving out of the mon. It can be scary though. Like PGs can be shown as unknown, or like I mean that's the main thing I've noticed with the slow manager is that PGs show as unknown, and then state transitions are not updated quickly with if someone's watching Ceph status, for example.
Yeah.
Well, the other thing is that the manager, even though it was supposed to be something that can be, that can fail and isn't necessarily available, it wasn't supposed to affect the data path. There is more and more things that are added. One example, for example, on the RBD side is the deferred deletion of RBD images or purging of RBD trash. If the manager is down or just being very slow, then that would be delayed, and it, in a sense, it starts affecting the data path because it has to do with the amount of data that is stored in the cluster. I think the same goes, or similar goes for CephFS, where the entirety of the subvolume management lives in the manager, and so if when Kubernetes when a Kubernetes user requests a volume, that goes through the manager, and if the manager is down, as far as the Kubernetes user is concerned, like nothing works, or at least new PVCs wouldn't bind and things like that. So the manager is becoming, more and more of a critical component that we cannot that can be slow. I guess that's the point. And that was the one of the core observations, behind Jason's proposal to move to not look into short-term things that we can do. That's probably there is probably a lot of things that can be done to optimize the existing Prometheus module based on Cherry Pie. And whether it's moving more stuff into C++ or just drastically cutting down the number of perf counters that are getting translated into plain text and then exported, there are various ways to get some short-term gains here, but long-term, with more and more things that are from the user perspective are critical. Being living in the manager, I think we really need to move everything that has to do with metrics out of the manager, whether it's a per daemon endpoint or something just a per node endpoint to address the security concerns raised by Casey. That can be that has to be discussed, but I think we should not conflate the short-term things that can be done and the long-term goal of moving, basically, getting rid of the Prometheus module in its current form. We would likely need something in the manager still to point, to list out all the endpoints, so things like that. Perhaps some other auxiliary functionality, but the metrics themselves should really not go to the manager because it has other responsibilities now. I guess that's the best way to put it.
Ilya, I've always been a little suspicious and worried that the manager has kind of turned into the dumping grounds of other things that we didn't want in the mon, and it's kind of almost now becoming its own critical piece of infrastructure for clusters that is not resilient and is based partially at least on Python.
Yep.
Is that
well? The based on Python part is not a problem as long as it's really about like management. For example, creating a CephFS subvolume or marking the image, an RBD image for deletion, and managing that deletion. That's totally fine, and that's there's nothing wrong with using Python there. Shoving dozens of megabytes per second through the Python interpreter probably can be optimized, but just not a good idea, especially given that there is no upper bound on that amount of data. We're talking about right now all of the data that goes through the exporter. That's basically OSD data, and the number of OSDs is more or less bounded. We're talking about setting up and exporting metrics and multiple metrics per RBD image or RGW bucket, and the number of those can be orders of magnitudes greater than the number of OSDs. So talking about about measures, about priorities and whether we can maybe just export less. Again, in the short term, it may bring some fruit, but longer term, we will be back to 50 megabytes or 100 megabytes, just because there will be a lot more metrics that we want to make available that we are being pressured to make available.
Yeah, I think what I was kind of trying to get is it feels like we've almost recreated the exact same problem we had in the mons now in the manager, right? Where we have these critical things that need to happen that are impacted by metrics data that we're collecting, and we're
right.
kind of back to square one again.
Right.
And now maybe even a worse position than we were before, almost.
Yeah, I've been saying that all along but the manager is becoming almost a monitor, at least if you consider Kubernetes environments. There is a lot of things in RBD and in Ceph right now that depend on the manager. And not only things like image and volume management, but also disaster recovery. So the entirety of snapshot scheduling for snapshot-based RBD mirroring and Ceph mirroring, which is always snapshot-based, all of that also lives in the manager. And yeah, from the point of view of like the end user, while it's not strictly in the data path, from their point of view, it almost is, because if the manager is down, this means that your data stops replicating to the secondary cluster. If you set up disaster recovery, like if you set up regional DR in Kubernetes terms. And there are other examples.
I would just like to add that despite the final decision on whether to move this to a separate exporter or not, there are at least 6 modules that consume the Puff counter API, major API. So just for everyone to keep that in mind. So with that, I'm not sure if what we are proposing here is that all these modules should scrape the data from Prometheus instead of from the manager API, or we still plan to leave this API available in that. And additionally, I'm a bit fearful about the fact that we are facing a bottleneck because we currently have a single point of failure, which is the manager, but we are moving the same amount of metrics to different components that are going to generate not only that traffic, but extra traffic, right? We are talking about that. And that's going to be routed to a single point of failure, which is a single Prometheus instance. Unless we are planning to vertically or horizontally scale the Prometheus cluster.
That's fair, but isn't that part of? I mean, if it didn't have any way to do that, that would be one thing. But I mean, that's a design choice. It's fair. We guess we have to analyze that. But I mean, but it has ways of scaling, right?
Yeah. But I guess it will be harder. I mean, we don't know exactly what's the traffic and the throughput of metrics that we're generating. But if we distribute this across 2,000 OSDs plus X all other demos, right? It will be harder to know where the traffic is coming, and so it might be more scalable, but yeah, it will be harder to coordinate and orchestrate. Just to keep that in mind.
Yeah, I think Prometheus will need to scale regardless of the strategy used. Like Leila was describing, we're going to be sending lots more data from mirroring metrics and from all the different components, in addition to the current data set. But I think that's something to keep in mind. We will need to think about scaling Prometheus, but it's going to be in the mix regardless. What are the other modules that are using the perf counters today? I know there's telemetry, which is like once a day, so that one could be easily separated, doesn't need to be constantly updated.
Yeah, I just grabbed and I saw, well, basically all the metrics related modules, the influx one, telegraph, and the RESTful. Probably we could deprecate that. Yeah, and dashboard and Prometheus. Those are the all of them.
So the IOStat module, I believe. Seeing some perf counters or no, never mind. I something else. Never mind.
Okay, so the other metrics collection modules are also using the same interfaces. They would probably face similar problems. What about the dashboard?
Dashboard displaying the metrics on demand. So only if you access the given daemon details, you will see that it is not preemptively or well prefetching the metrics as the Prometheus module. So it's easier at least to identify spikes on and load due to that.
Yeah, I think we talked about dashboard needing to display metrics when we were discussing the moving out to the individual daemons approach, and I think what our agreement, which as far as I remember, was that since Grafana can be basically pointed at the same data stream, and the idea was that the dashboard would just have an embedded Grafana instance that would basically handle the scraping the same way that a Prometheus server would. I'm not sure, like maybe it's wrong, but this was actually seen as a step forward, because today we have like the same perf counter data that is delivered to the manager. That data is interpreted by the dashboard and by the Prometheus exporter separately. And the idea was that here we would have a single set of data and a single sort of viewpoint, because there wouldn't be two different pieces of code that are essentially parsing out the same stuff. Yeah, again, I've only been tangentially involved in those conversations, but I think that was the idea.
I think the data centralized in a Prometheus to be queried by Ceph dashboard is an interesting idea. Definitely, we would have just one source of truth. On the other hand, Ceph dashboard, I'm not sure how detailed the data can be queried, because Ceph dashboard does not require as much data as Prometheus does and doesn't collect at all. It's just requested for being displayed. And moving the ability of manager modules away to query such data would require Ceph dashboard to use Prometheus, to have a Prometheus instance to be able to display rudimentary performance data, which currently does not depend on Prometheus nor Grafana. The other thing is I do think that, I mean, I know that different monitoring systems, and we have, for instance, a Zabbix module in the manager. They do have different models, so not every monitoring pulls the data. Some expect it to be pushed, but I think most do that using HTTP. So if the data to be queried from Prometheus as HTTP servers, it could be provided in a different format, and it could even be pushed to different monitoring solutions. That would be one way to get rid of the manager. Yeah, the need of the manager to provide those metrics, data.
So you're suggesting we could have something like a manager API to access the metrics for different modules that need to look at them at the dashboard, or maybe telemetry, or maybe other modules in the future that might want to analyze performance data from the cluster. That would go back to Prometheus or potentially other backends if folks wanted to implement other sorts of monitoring.
Just it's not difficult to access the data from Prometheus. It has a stable API. It follows semantic versioning, and I've never had an issue with upgrading Prometheus. But it would be a component that would then be required to some extent, where before it wasn't.
Yeah, and additionally, the manager is meant to be highly available, while Prometheus, well, unless you really deploy a highly available architecture around Prometheus, it is not. So if you lose Prometheus, then you basically lose the metrics.
Yes. And the Prometheus guys state that it is not a good idea to use distributed storage or redundant storage on top of Prometheus, and they would rather suggest that the Prometheus instance gets basically two Prometheus instances get their same configuration and do their job independent of each other. And in terms of storage, it might become necessary at some point to not only because of storage, but also because of scaling. We use several Prometheus instances to scrape different types of exporters and do that redundantly so that they would be distributed. That would be actually the way Prometheus is supposed to be used if necessary to be scaled. And there's this option that the Prometheus instance could scrape other Prometheus instances to get the high level view of things.
Yeah, it's interesting. I think it seems like there could be some more investigation into how we could architect the Prometheus side of things to make that work well for components. Are you suggesting Thanos when it is shared from Prometheus? I'm not familiar with that.
It's sharded Prometheus.
Oh, sharded.
Yeah, it's basically a lot of Prometheus sharded and but I wouldn't start with it. I would start with basically you can use the same exposures. It doesn't matter. It's still open, same protocol, so it's fine.
Yeah, there's some derivatives to Prometheus which I do not know very well, but which claim to be doing some parts of what Prometheus does better. For instance, Prometheus does not claim to be a long-term storage. The data is compressed, metrics are compressed, but the sampling rate is not reduced. And a system that does long-term storage would be expected to reduce the sampling rate.
All right, well, we've had a long discussion already, and we've kind of covered a lot of different areas. I think we have an agreement that you want to split things out and from the manager in general and make that process scalable. Sounds like we still need some more investigation to figure out exactly the best way to do that. What do folks think the next steps would be? That Jeff would follow, or Ernesto or Patrick? Would you guys be looking into more experiments here? Or?
I think Paul is driving some work with Pere and Avan, I think, from Dashboard, but I don't see them here. Nope. Okay, so yeah, basically, yeah, Avan's here. Kevin, can you summarize more or less what have you talked with Paul about the actions, the short-term actions that you are planning for this?
Well, he said basically we will send by the end of this week, but to start, he just asked to fetch the number of metrics which Ceph is using, for example, the dashboard and the alerts in the alerts as well. So we figure out, and those were around kind of 130 or so. I mean the unique metrics also. I can fetch the exact numbers, but yeah, it was around that, I guess. So yeah, that was the initial step we asked.
Okay, thanks.
Okay, any final thoughts on this area or anything we didn't cover?
So I'm just confused by the outcome and the decision. So we're going to move forward with the POC. We're going to distribute to daemons. We're going to distribute to nodes. We're not going to do anything in that regard. So I'm just confused. I sat through the whole thing, and I'm just wondering, what do we decide?
I think I'm a little confused about the daemons versus nodes distinction as well, but with the extra information about how exporters function and how they have their own frequencies and sets of metrics. Sounds like we maybe need some more design around how that might look. We could start out with one way, just having it per daemon and potentially scale to multiple architectures in the future. But I think we need to maybe sit down and figure out how that might make sense. And
so it sounds like doing the prototypes that we're talking about is very important. We'll continue that work.
Yeah.
And we'll continue doing it probably, I'm not sure, whatever direction we deem appropriate, whether it be per daemon for now, we'll go that approach, I guess. And we'll basically, come back with the appropriate, decisions as a result of that work, along with the interval periods and differing interval periods, how we can deal with that, et cetera. So that sounds reasonable. Sure.
Yeah, it sounds good to me. What do the folks think?
Well, I think as far as something short term, the idea to only serialize performance counters that are either above or under a certain limit, depending on how you look at it, a certain priority. I imagine some of the priorities may not be may not reflect the actual priority, since we've never really, just as with log messages, these tend to be assigned semi-randomly with not much thought put into that. So if we were to, pick a priority level as a cutoff, and then do an audit, and make sure that there's nothing. That there are no bulky, entries that generate a ton of data above that priority. Then in the short term, we could cut that 50 megabytes to something more reasonable. So if you have resources to look into that and allocate for that, then I would definitely do that, because this seems to me like a low-hanging fruit that would provide a significant benefit. other tthan that, yeah, continue the experimentation with either per daemon or per node exporters still seems like the best long-term approach to me. The point in the wiki about bringing true active, load balance and scalability to Ceph managers and making them truly highly available is definitely also something that is worth looking at. But I don't feel like even if the manager was highly available today, which I don't think it is, I don't see how that would how that solves the metrics issue. Even if you had, say 3 managers that were active at the same time, how would you partition the work that Prometheus needs the manager to do among those, given the requirement that when the Prometheus asks for data, you need to provide all of it, and it needs to be consistent with each entry needs to be consistent with respect to all other entries for that instant of time. So I don't see how you could partition that among the multiple active Ceph managers, even if that was supported today. So it feels like moving out to either per daemon or per node is really the only realistic option that we have. But again, that's just my opinion.
Yeah, I agree. I think the manager scalability and active piece is a bit of orthogonal to the metrics collection. I think that we want to move that out of the manager regardless.
Yeah, I can see. I'm not sure who wrote this wiki entry. Might have been Paul. This last point here about diluting or undermining the purpose of Ceph Manager, that I would actually disagree with, because while it is super convenient to dump a piece of Python there, it wasn't intended for this sort of thing. The PGA, like the original motivator, which was the PGA stats, right, and all of the related data, that is again that is bounded in all aspects, not just the size, but also the shape of the data. With us moving to exporting per image and per volume, per bucket, whatever data, there's no upper bound on that, because you could have a ton of tiny images, and each of which would have its own set of metrics that again needs to be depending on the interval, which we don't really control. I mean, we can say that we don't support something that is less than whatever number of seconds, but still, that's not a very good solution, in my opinion. So it needs to be decentralized. I think that is something that we just can't argue with.
Ilya, I wrote that second part of that. The first one, I think it was false. Yeah, well, the undermining of diluting, it's about the feeling that actually you mentioned the PG stats, and the PG stat has caused the serialization of that has caused issues in the past, and same for the OSD map. So even if those structures are quite bounded, well, under some circumstances, serializing such a big chunk of data has caused. So it's not just probably the metrics alone. It is the combination of the metrics plus other goals that all of them basically contain for the yield and the logs and all that stuff. So part of the active suggestion was decoupling this interaction might also improve the overall performance of the manager. So it is not, horizontal scaling the perf counters, but maybe just pinning different modules to different managers might also improve the performance, the overall performance. In the end, I mean, if we have to install an exporter in every module, what are we going to call that? A Ceph manager, something? So it's kind of evolving to a new daemon that is going to live together with a sidecar module that is going to live together with the other ones. So I feel it's kind of reinventing the manager. So I was wondering if we could make that new module from the manager, from the ashes of the manager or whatever, right? If we can somehow tweak it and to fulfill this requirement, because in the end it's going to be a new Ceph service, or so it's basically going to interact with the perf counters of every daemon, which is partly what the manager is doing, if I'm not wrong, right? So yeah, it's like creating two different channels for reporting perf counters, and so that was connected to that suggestion. Exploring the HA, the active HA.
I think the idea is that each collector would collect from its own daemon, so you don't have a centralized thing that need to know about the stats of all daemons. The whole point is that whatever collects data from the RGW knows the counters of the RGW, whatever collects data from the OSD knows the counters of the OSD, and that's it. And just send them to Prometheus. It doesn't do anything else.
Yeah, but I think one of the suggestions from Paul is about having a sidecar exporter, right? Which I guess is exporting all the metrics of the collocated daemons, right?
Well, what's necessary, as I understand it, is that Prometheus can find the exporters. So one way or another, we have to keep track of that.
Right, but the exporter could be very specific to the daemon that it's collocated with, and just take the data from it and send it to Prometheus, or put in somewhere that Prometheus can take this information from.
Okay, but in that case, are we talking about having separate exporters per type of daemon? So would we have like an OSD exporter for a sidecar exporter and another one for RGW endpoints? That is the idea, or?
I don't see why it would be necessary to have multiple on a node.
Okay.
It kind of depends. So if you run it as a sidecar, for example, if it uses something that is specific to the daemon, like using a Unix domain socket, then it would be a specific exporter for each daemon, because each daemon running in its own pod, right? And they can all just pull from other pods because it would be different namespace. At least in the Kubernetes deployment, this is usually the approach.
Yeah, I think I'm not sure we have the information to make a final decision on the architecture exactly right now, but I think we can experiment with a few different ways to have this kind of like sidecar approach and see what works well and what scales with Prometheus as well. Like it could end up being a scalability problem for Prometheus, or we might need to scale Prometheus more. We have thousands of exporters. I'm not sure.
Does it exist a proxy on the endpoint side so that we could have still have one exporter for the entire cluster that would run as a new daemon, and it would know about all of the thousands of exporters on all the daemons, and anyway, so like, and eventually your Prometheus would only query one endpoint, it would aggregate and maybe cache or whatever. I guess I'm just saying all the existing Prometheus stuff, spin it out to a separate daemon, a separate single daemon. Maybe that's, I don't know if that's simpler or more difficult.
Then I think that's extremely close, right, to the current architecture with the manager. So basically the manager is caching the perf counter, if I'm not wrong, right?
Part of.
And it's also centralizing that. So
Except unless you, but I don't know if it's a good idea, but it becomes mechanism agnostic then, right? Varnish cache in there, or a reverse proxy.
I think it has to nest things properly, right? Because you would be like one layer deeper. You would have to have a super layer, a higher layer, like OSDID, for example. It needs to be one. Okay. Yeah. I mean, I guess I'm just worried. I'm also like, if right now the OSDs are pushing the stats on there when they decide to, like when they have time. But if we start pulling the OSDs, I mean, we have to make sure that this can't disrupt the OSD important operations.
Well, in the node exporter model, there is a decoupling there. They probably push or get pulled on. Well, something happens there. It's either a super low overhead Unix domain interface where like the perf like we have now, or maybe it is the Abbott socket, or else it's going the other way.
Right. Yeah.
I don't think any of these would increase the load on the daemons themselves. It would be the same kind of collection mechanism that the Prometheus model currently uses, but it's just going to a different place and not necessarily being centralized. So there shouldn't be any impact on the running daemons.
If anything, if a Unix domain socket is IPC, it might be overhead might be less.
Yeah, that's true. Mark suggested that we could use some kind of delta, or only sending delta of metrics instead of sending everything out at the same time. At least between the daemons and the per node exporter, we could only send the deltas there, and then Prometheus would query the whole thing from the exporter.
Well, that's even stronger if you have a semantic compression as a guide.
But even today, I think it's not an issue. We're effectively, like Arthur is saying in the chat, using the same thing interface as admin socket commands to get the perf counters essentially, and it hasn't had any noticeable impact on the data path. So I guess in summary,
there was one issue in the past. I don't know if this has been optimized, but large clusters, you had to decrease the MGR stats.
Yes.
Interval. Like we use 15 seconds everywhere on our like 1,000 or 2,000 OSD clusters because the default 5 seconds is too much, and that kept the MGR too busy. Yeah, in that case, yeah, that did not impact the OSDs themselves. That was actually just load on the MGR. Yeah, fine.
I do remember seeing in Crimson in the reactor thread, at least with Blue Store, that work actually was, a moderate contributor to time in the reactor on the order of like 5 or 10%. So in that kind of a model, it might actually be a thing we need to watch carefully.
Yeah, I think the Crimson piece is a separate issue. That's probably more likely a bug, but we can figure that out later. But I think for now, we have a lot of good ideas here, a lot of interesting things to explore in terms of the how the different architectures will scale. Is there anything else that folks want to add at the moment?
Well, yeah, I just want to remind people that the use case for mirroring and replication wants to use finer grained metrics than the existing perf counters supports. So if we're just talking about rewiring how perf counters work, we also need to figure out how to extend them to cover these new use cases.
Yeah, I agree. I definitely do want that.
Yeah, definitely.
And Paul, you heard the phone call. I mean, I don't want to waste more time, but Paul had ideas about the Prometheus side. About the data. structure,
Mm-hmm.
the direct export side.
Maybe we can come back to the next CDM, which would be more friendly to Paul's time zone, and hear more about that Prometheus architecture aspect and kind of what he's figured out at that point. Any other topics folks want to bring up today? All right. Well, thanks everybody for the great discussion, and see you next month.